Science 10, Lesson 10, Drawing Organic Molecules. Organic molecules, what are they? Well, they are the molecules that make up all living things like plants and dinosaurs. And when a dinosaur dies, it's the oil that they turn into and the gas and the oil that we then use to make swanky Back to the Future shades and the plastic containers that we put our freezies inside of. And they also make up the artificial colors and flavors that are in the freezie and the Lego and t-shirts, which are mixed with cotton, which is another organic. And organics are also things like sugars and plastics. Did I mention that? Like this cool dog hat. And the dog itself is organic. And that stuff that gets stuck to the inside of your oven, that's organic as well. And the potatoes and squashes from this year's harvest and the wood that was used to make the blocks for that and grasshoppers is a weird bug and all that stuff that I tried to pack into the back of my SUV. Well, the majority of that stuff was made out of organic molecules. Drawing organic molecules. An organic prefix is used to identify the number of carbon atoms that have formed a chain. We are going to be using the organic numbering that is found on your formula sheet. Meth is 1, eth is 2, prop means 3, bute means 4, pent means 5, and so on. Carbon atoms make 4 bonds, so hydrogen is added to fill in the rest of the carbon bonding potential. If we see that a carbon is only making 3 bonds, then we'll add a hydrogen to that carbon because all carbons make 4 bonds. If the organic name ends in An-ene, the molecule only contains single bonds between carbon atoms. Make a note on your formula sheet that ane means single bond. If we have methane, meth means 1. So underline meth, and under that, write 1C. Ane means single bond. So underline ane and write SB. So methane means 1 carbon, single bonds. So I draw 1 carbon, and to make sure that it has 4 bonds, I will have to fill in the rest of its bonding potential with hydrogens. So since it currently makes no bonds, I will have to add 4 hydrogens bonded to that carbon, so the carbon is making 4 bonds. And that is methane, also known as natural gas and farts. Ethane. Eth means 2. So underline eth and under it write 2 C's. Ane means single bond. So I have 2 carbons singly bonded. So I draw 2 carbons with single bonds. Each carbon is only making 1 bond. So to ensure each carbon's making 4 bonds, I add 3 hydrogens to each carbon. Now each carbon is making 4 bonds. Propane. I want you to underline prop. And we see that prop means 3 carbons, so under that write 3 C's. Ane means single bond. So propane means 3 carbons singly bonded. So I draw 1, 2, 3 carbons singly bonded. The first carbon is only making 1 bond, so I add 3 hydrogens to it so it can make 4. The middle carbon is making 2 bonds, so I add 2 hydrogens to it so it's now making 4 bonds. And the last carbon is making 1 bond, so I need to add 3 hydrogens to it so that it is now making 4 bonds. And that is the formula for propane. For your barbecue. An ene ending in the name means there is a double bond. If there is more than one location the double bond can be placed, a number will be included to tell us where it is located. On your formula sheet, I want you to make a note that ene means double bond. If we have ethane, I want you to underline eth. On our organic numbering, it says eth means 2. So underneath the eth, write 2 C's. I want you to then draw 2 C's. Ene means double bond. I want you to underline Ene and underneath it write DB for double bond. So if I read this, ethene means 2 carbons double bond. So I will now add in a double bond between the carbons. So each carbon is now making 2 bonds. And since all carbons need to make 4 bonds, I will add 2 hydrogens to each carbon so that each carbon is now making 4 bonds. 1. Butene. Underline but. But means 4. So under but, write 4 C's. And we'll draw 4 carbons. Now underline ene, and under that write DB for double bond. Draw an arrow going from ene to the 1, because the double bond is located on the first carbon. So we will number our carbons, 1, 2, 3, 4, and we'll place the double bond on the first carbon. Now we write our hydrogens. The first carbon needs 2 more bonds, so I put 2 hydrogens on that first carbon. The second carbon needs 1 more bond, so I put 1 hydrogen on that carbon. The third carbon is making 2 bonds. It needs 2 more, so I place 2 hydrogens on that carbon. And the last carbon is only making 1 bond, so I add 3 hydrogens to the final carbon. So let's say instead of 1 butene, we had 2 butene. Well, but is 4 carbons, so we draw 4 carbons. Ene is double bond, but this time the double bond is on the second carbon. So we number our carbons and place the double bond on the second carbon. Now we add hydrogens to each carbon so that each carbon is making 4 bonds. So the first carbon will need 3 hydrogens added to it. The second carbon will need 1 hydrogen. The third carbon will need 1 hydrogen. And the fourth carbon will need 3 hydrogens. Now each carbon is making 4 bonds. An OL ending means an alcohol. An alcohol is an OH group connected to the chain of carbons. If there is more than one possible location for the OH group, a number will be found in the name to identify where it is to be placed. I want you to add to your formula sheet that OL is an alcohol, an OH group. Let's say we have 1 propanol. Prop means 3. So I have 3 carbons. So let's draw out 3 carbons. 1, 2, 3. An means single bonded, so I will write SB, and OL means I have an OH. And that OH is located on the first carbon. So I put the OH on the first carbon in the 3-carbon chain. Now to make sure that each carbon is making 4 bonds, I will add hydrogens. So the first carbon needs to have 2 hydrogens added to it. The second carbon needs 2 hydrogens added to it. And the third carbon will need 3 hydrogens added to it to make sure that every carbon is making 4 bonds. Ethanol. Eth means 2, so underline eth and write 2 C's. Then we will draw 2 carbons connected by a bond. An means single bond. OL means OH. So I have 2 carbons singly bonded with an OH group attached. Now, you're probably wondering, where do I put this OH, because it didn't give me a number. Should it go on the first C or the second C? And the reason you were not given a number is because it doesn't matter. So let's say I put it on the first C. Well, here's an identical molecule, right? And if I flip that molecule, if I rotate it, I wind up with the OH on the second C. It's the same molecule, just flipped. And that is why it doesn't matter. These two molecules are identical, just flipped, and that is why they did not include a number, because it doesn't matter which C you put the OH onto. Now I finished by adding 2 hydrogens to the first C and 3 hydrogens to the second C, and that is ethanol. 2-butanol. But means 4, so write 4 C's. Then I will draw 4 carbons connected by single bonds. Ane means single bond, so write SB, and OL means alcohol, so write OH. So I have 4 carbons singly bonded with an OH group, and that OH is going to go on the second carbon. So I number my carbons, and on the second carbon in, I will attach an OH. Now I add hydrogens to make sure that each carbon is making 4 bonds. So I add 3 hydrogens to the first carbon, 1 hydrogen to the second carbon, 2 hydrogens to the third carbon, and 3 hydrogens to the fourth carbon. If there is an alcohol and a double bond, the number for the alcohol will be moved to the end of the name and comes just before the OL ending. Let's look at 3-butene-2-ol. BUT means 4, so write 4 C's. And let's draw out then 4 carbons. 1, 2, 3, 4. Ene means double bond, and the double bond will go on the third carbon. So number your carbons, and on the third one in, we will put a double bond. OL means we have an OH, and the OH will go on the second carbon. So on the carbon labeled number 2, write OH. Now add hydrogens so that every carbon is making 4 bonds. So the first carbon will need 3 hydrogens, the second carbon will need 1, the third carbon will need 1 more bond, and the fourth carbon will need 2 hydrogens added to it. 1-propene, 1-ol. Prop means 3. So I have 3 carbons. So I will draw out 1, 2, 3 carbons. Ene means double bond, and that double bond goes on the first carbon. I also have an OH group, and that also goes on the first carbon. Now I add hydrogens to make sure that each carbon has 4 bonds. So I add 1 hydrogen to the first carbon, 1 hydrogen to the second carbon, and the last carbon will need 3 hydrogens added to it so that it is making 4 bonds. 2-pentene, 1-ol. Pent means 5. So I write 5 C's. Now I draw 5 carbons. 1, 2, 3, 4, 5. Ene means double bond, and the double bond goes on the second carbon. So I number my carbons, and second carbon in, I will place a double bond. I also have an OH, which goes on the first carbon. Now I add hydrogens to make sure that every carbon is making 4 bonds. So I add 2 hydrogens to the first carbon, 1 to the second, 1 to the third, 2 hydrogens to the fourth carbon, and 3 hydrogens to the fifth carbon. Now every carbon is making 4 bonds. If there is more than one double bond, a covalent prefix is used to identify the number of double bonds in the molecule. There will also be a number given for each double bond to identify where it is located. If I have 1,3-butadiene, but means 4. So write down 4 C's and then draw 4 carbons. 1, 2, 3, 4. Di is a covalent prefix meaning 2, and ene means double bond. So butadiene means 4 carbons, 2 double bonds. I've been given 2 numbers that tell me where those 2 double bonds are located. I have a double bond on the first carbon and the third carbon. So I number my carbons, and I place a double bond right after the first carbon and right after the third carbon. Now I add hydrogens to make sure every carbon is making 4 bonds. So I add 2 hydrogens to the first carbon, 1 to the second, 1 to the third, and 2 to the fourth carbon. Now they are all making 4 bonds. 1, 2, 4, pentatriene. Pent means 5. So I have 5 C's. So 1, 2, 3, 4, 5 C's. Tri is a covalent prefix meaning 3, and ene means double bond. So 5 carbons with 3 double bonds. And the double bonds will be placed on the first, second, and fourth carbon. So I number my carbons. I place a double bond right after the first, right after the second, and right after the fourth carbon. Now I add hydrogens to make sure that every carbon is making 4 bonds. So I add 2 hydrogens to the first carbon. The second carbon does not need any because it is already making 4 bonds. I need to add 1 hydrogen to the third carbon, 1 to the fourth, and 2 to the fifth carbon. If there is more than one alcohol, a covalent prefix is used to identify the number of alcohols in the molecule. There will also be a number given for each alcohol to identify where each OH is located. 2,3-butanediol. But means 4, so write down 4 C's. And now draw 4 carbons. 1, 2, 3, 4. Ane means single bond. Di is a covalent prefix meaning 2, and OL means I have an OH group. So butanediol means 4 carbon singly bonded 2 alcohols. The 2 alcohols will be located on the second and third carbon. So I will number my carbons and place an OH on the second and the third carbon. Now I add hydrogen so that each carbon is making 4 bonds. So I add 3 hydrogens to the first carbon, 1 to the second, 1 to the third, and 3 hydrogens to the fourth carbon. 1,3,5-pentane triol. Pent means 5, so I have 5 C's. So draw out 5 carbons. 1, 2, 3, 4, 5. Ane means single bond. Tri is a covalent prefix meaning 3, and all means I have OH groups. So 5 carbons singly bonded with 3 OHs. And those OHs will be attached to the first, third, and fifth carbon. So I number my carbons. I add a OH to the first, the third, and the fifth carbon. Now I add hydrogens to make sure that each carbon is making 4 bonds. So I add 2 to the first carbon, 2 to the second carbon, 1 to the third, 2 to the fourth carbon, and 2 hydrogens to the fifth carbon. 2-butanol. But means 4, so I have 4 carbons. So I will draw out 4 carbons. 1, 2, 3, 4. An means single bond. Ol means we have an OH and it goes on the second carbon. So I place an OH on the second carbon, and then I add 3 H's to the first C, 1 to the second, 2 to the third, and 3 hydrogens to the fourth C. Now all my carbons are making 4 bonds. Propene. Prop means 3, so I need 3 carbons. So I draw out 1, 2, 3 carbons. Ene means double bond, so I insert a double bond. Again, just like seen earlier in the lesson, I was not given a number. If the double bond went on the other side after the second carbon, Well, that would be the same as putting it on the first, because if I flip the molecule, it would be identical to what I've drawn here. Now I fill out the rest of the carbon bonding potential with hydrogens. So I add 2 hydrogens to the first C, second C gets 1 H, and the last C requires 3 H's. Now all carbons are making 4 bonds. 2-hexene 2,3-diol. Hex means 6, so I have 6 carbons. So I draw out my 6 carbons. 1, 2, 3, 4, 5, 6 carbons. Ene means double bond, and that will go on the second carbon. So I number my carbons and place a double bond after the second carbon. Di is a covalent prefix meaning 2, and OL means OH. I have 2 OH groups, and they will go on the second and third carbon. So I put an OH on my second carbon and on my third carbon. Now I add my hydrogens. I need 3 on my first carbon. My second carbon is already making 4 bonds as well as my third, so they will not need any hydrogen. My fourth carbon needs 2 hydrogens, my fifth needs 2, and my sixth will need 3 hydrogens so that every carbon is making 4 bonds. Octane, my final example. Oct means 8, so I need 8 carbons. So I draw them out. 1, 2, 3, 4, 5, 6, 7, 8. Ane means single bond. So that means I have finished this molecule with the exception of filling in the hydrogens to make sure every carbon is making 4 bonds. So here we go. Ba-ding, dang, done. And that's the end of the lesson. You're good to move on to the assignment.